Hello, welcome to the lecture course CHO 351 for MSc-II organic class. In previous lecture, we have discussed approximate 13C chemical shift value for selected type of carbons. Also, we have discussed that in exam there are three type of problem may be asked. First is the assign the 13C chemical shift value to various carbon in the following compounds. Also, deduce the structure from given C NMR data. Also, third is deduce the structure from given C NMR as well as 1H NMR data. So these are the three type of problem may be asked in exam. Also, in last lecture we have discussed that first type of problem, it is assign the 13C chemical shift value to various carbon in the following compounds. In that we have discussed the two examples. So in this lecture we will continue our discussion with problem 3, that is the assign the 13C chemical shift value to various carbon present in the following compounds. So problem 3. So question is assign the 13C chemical shift value to various carbon. So signal is given firstly 137 singlet, 108 singlet, 136 singlet, 61 doublet, 128 singlet, 56 triplet, 121 singlet, 55 quadruplet, 118 doublet, 54 triplet, 117 doublet, 13 triplet, 111 doublet, 26 triplet, then 25 triplet and 22 triplet. So structure is given. So for this compound, you have to assign this 13C chemical shift value to various carbon. So here, same like last time, that is the with the help of number of proton attached over each carbon, we can predict that this carbon should have signal quadruplet, this should doublet, this should singlet, this should doublet, this should singlet, this should singlet, this should doublet. Okay. Then this should singlet, this should singlet, this should triplet, this should triplet, this should triplet, this should doublet, this should triplet and triplet. So in this way we can predict that with the help of number of proton or number of hydrogen attached over the carbon, we can predict the signal given by each carbon. So here signals are given. So in this structure, from this structure we can conclude that this compound is actually unsymmetric compound, and because of unsymmetric compound, here no carbon is equivalent here. So each carbon gives a different signal. If you observe this structure, from that we conclude this, that is this structure does not contain any equivalent carbon or symmetrical equivalent carbon is not present here. Okay. So here, firstly, for methoxy group, because of oxygen attachment and quartet signal is given here, that is the 55 quartet. So for this methoxy group, we can assign the value, that is the 55. How much? 55 quartet. Okay. So 55 quartet, that is the signal you can assign for this. Then remaining signal, in that if you observe that this 61 doublet because of this carbon. So for this carbon we can assign the 61 doublet. Okay. So because of nitrogen attachment, nitrogen is one of the electronegative element. So because of nitrogen attachment, we can observe that this chemical shift value for this carbon 61 doublet. Also, there are two carbon which is attached to nitrogen, also these two. Okay. So here 56 triplet and 54 triplet. So this carbon we can assign the 56 triplet and this, that is the 54 triplet. Okay. In this way, this carbon is attached to further, after one carbon attached to aromatic carbon. So because of that we can assign the 56 to this 54 triplet. Okay. Then remaining 56 and 54. Then 25 triplet, 22 triplet, 26 and 30. So this carbon we can assign the 13 triplet because of attachment to aromatic carbon. Then remaining signal, that is the 26, 25 and 22. So to this carbon we can assign the 26 triplet. Then to this carbon 25 triplet and this carbon 22 triplet. So as distance from electronegative element is decreases here, chemical shift value is decreases here. As 22 triplet we can assign to this carbon, and to this 26 and to this 25. So because this carbon is attached to, that is the secondary carbon, while this is attached to primary carbon. So because that we can assign the value like this. So in this way we can assign 26, 22, 25 all this signal over this structure. Also we assign the 61 double also here. So remaining signal for the aromatic carbons. So here most distillate at 137. So because of what? Because of oxygen attachment, so we can observe the 137 singlet to this carbon. Then also next is the 136. So 136 to this carbon because it is attached to further nitrogen. Nitrogen attachment 136 singlet. Then next is the that is the 128 singlet we can assign for this carbon, that is the because of nitrogen attachment 128 singlet. Okay, it is the 128 singlet, and remaining signal, that is the 121 we can assign for this carbon 121, and then for this carbon we can assign the 108 singlet. Okay, so because of nitrogen attachment 128, 121 and 108 singlet for this carbon, and so we are assigning all the signal here singlet in aromatic carbons. So double is remaining here. So because of oxygen attachment here, this carbon we can assign the 118 doublet. Okay, and Also this 117 doublet to this carbon. This carbon is the 118 and this is 117 doublet. And remaining signal that is the 111. So this carbon 111 doublet. So in this way we can assign the 13C chemical value over the structure by considering the electronegativity, also hybridization, and third is the diamagnetic anisotrophic effect. So in this lecture also we are going to consider the second type of problem that may be asked in exam, that is the deduce the structure from given CMR data. Okay. Deduce the structure from given CMR data. So, deduce the structure, second type of problem, question is like deduce the structure from given CMR data. Okay. So, this is the second kind of problem. So, in this problem, molecular formula is given C9H11NO. CMR information at 39.7 quadrant strong, 1110.8 doublet strong, 124.9 singlet weak, then 131.6 doublet strong, 154.1 singlet weak, and last is the 189.7 doublet and weak. So this kind of information is given. And from this information you have to deduce the structure from CMR data. So this quadrant doublet, singlet, doublet, singlet, doublet. This is nothing but one bond coupling we consider here with protons. Means off resonance decoupling 13 C NMR spectra information is given here. And here strong, strong, weak, strong, weak, weak. This is nothing but intensity of the 13C chemical value. Okay. So here, firstly, for this problem, we have to find out in solution, we have to find out the site of unsaturation. So site of unsaturation, we have to calculate by this formula, that is the C minus, that is the numerator C minus H by 2 x by 2 plus n by 2 plus 1. So by this formula we can calculate the site of unsaturation. So here oxygen is present in molecular formula. So we have to neglect this oxygen. So our molecular formula becomes C9H11N. So after neglecting oxygen, this is our modified molecular formula. After neglecting oxygen. So neglecting oxygen we get molecular formula. So you have to put the carbon number 9 here, hydrogen 11 by 2, X is the 0 by 2 plus 1 by 2 plus 1. Okay. So 9 plus 1 is nothing but 10. Okay. Minus 11 by 2 plus half. Okay. So by this calculation, 10 plus 1 by 2, 11 by 2. Okay. So this is nothing but 23 by 2 minus 11 by 2. 23 minus 11 by 2 is nothing but, that is the, not 22, sorry, this is 21 by 2. 2 into 10, that is the 20 plus 1, that is the 21 minus 11. So because of 10 by 2 this become so 5. So in possible structure from this CMR data contain how much site of unsaturation, that is a 5. How much? 5. So in possible structure there are 5 sites of unsaturation present. So 5 sites of unsaturation may be present in possible structure. Okay. So here if you observe the signals 1, 2, 3, 4, 5, 6, and here number of carbon is 9, and signal, if you observe that there are 6 signals. How much? 6. And in molecular formula 9 carbons. Obviously we can say that there are some carbons. There are how many carbons? We can say that there are overall 3 carbons that give the same signals. Okay, because of that here how many signals? 6. So this strong indicates that this signal may be because of, see, here strong signal. So this strong signal indicates that this may be because of 2 carbon. Okay, so this may be because of 2 carbon. Also this signal strong may be because of 2 carbon. Okay. Also last strong. This strong signal also indicates that this is because of 2 carbon. So this 2, 2 and 2 becomes 6, 7, 8 and 9. See here, 2, 2, 2, 6, 7, 8, 9. In this way, we can predict the information from CMR data. So these 2 carbons give the same signals here. Also here, these 2 carbons give the same signal. Here also 2 carbons give the same signal here. So here, possible structure contains 5 sites of unsaturation. Okay. So possible structure contains 5 sites of unsaturation. So first signal, that is 39.7 quadrant, indicate that in our possible structure there are 2 methyl groups. How many? 2 methyl group is present, which is an equivalent. 2 methyl group, which is equivalent here. Okay. Then next is the, if you observe the next signals 1, 2, 3 and 4, that is the 110.8, 124.9, then 131.6, then 154.1. So in these 2 signals, so all these signals are because of aromatic carbons. You know that aromatic carbons are 13C chemical value is from 1110 to 155. In this range we can observe the 13C chemical value for aromatic carbon. So in our possible structure aromatic ring is present. So for aromatic ring, how many sites of unsaturation? 4. Okay, and remaining 1 is for carbonyl group. Okay, that carbonyl group may be aldehyde or may be ketone or may be not here, may be amides. That possibly also possible here. Okay, so here 189.7. This indicates that carbonyl group. Okay, carbonyl group. This clearly indicates that you know that carbonyl group generally appear in the range above the 170. Okay, so this indicates that carbonyl group. But this remaining signal because of aromatic carbons. So these 2 signals 110.8 strong. Okay, also 131.6 strong. This indicates that this is because of 2 carbon. Okay, 2 aromatic carbon is equal. Here is also strong, indicate that 2 carbon are equal. Okay, so in aromatic ring 2 carbon are equal, and this weak because of 1 carbon. So this because of 1 carbon. Because of 1 carbon. So this is because of 2, this is because of 2, this is because of 1. So overall how much? 2, 2, 4, 1, 1, 5 and 6. So in this way we can predict that possible structure contains aromatic ring. And our pattern is a parallel separation pattern. Which pattern? Parallel. See here. Why we can predict the parallel separation pattern? See here. So X and Y is different here, but here so these two carbons are equivalent. These two carbons are equivalent. By symmetric consideration, these two carbons are equivalent. Give a signal in these two carbons. Give a signal doublet. These two carbons give a signal doublet with strong intensity. And these two carbons, which is the separation, this give a singlet. This also give a signal singlet with weak intensity. So in this way, we can predict that in our possible structure, para-disseparation pattern. Which para-disseparation pattern? Okay. So para-disseparation pattern, and over the para-disseparation pattern, two group is attached. So which group is attached? You have to identify here. So here, when you consider the aromatic ring is present, in the aromatic ring 6 carbon is involved and 4 hydrogen is involved. How much? 6 carbon and 4 hydrogen. So 6 carbon and 4 hydrogen. So remaining group is nothing but 3 carbon. So remaining group is 3 carbons, and there are how many hydrogens? That is the 7 hydrogens remain, and also 1 nitrogen remain. So also in our CMR data, 39.7 quartet strong means methyl group is attached to some electronegative atom like oxygen or nitrogen. Because of that, we can observe this chemical structure, that is 39.7. That is the quartet. There are two methyl groups that is attached to either oxygen or either attached to nitrogen. But here also you know that value 189.7 indicates that in our possible structure carbonyl group is present. So carbonyl means oxygen is involved. So obviously here 2 methyl group is attached to nitrogen, which is attached to nitrogen. So from this we can conclude that all this information, conclude that here 2 methyl group is present. This is attached to nitrogen. Okay, from this figure we conclude. Also there is a 1 carbonyl group is present, and so if you consider this remaining group, that is C3H7, so 2 methyl group is involved, so 2 carbon is involved, also 1 carbon group is involved, and remaining is only 1 proton here, that is H like this. So here how many hydrogen is involved? 6. Okay, from 6 if you from 7, if you minus 6, that time only 1 hydrogen remains. That hydrogen also involved in carbonyl group of aldehyde like this. So this type of situation may be present in our possible structure. Means aldehyde group is present at one position, and that is the dimethylamine. That group is present at other position. So from this information, we can conclude that possible structure. By considering all above information, we conclude that like this situation is present, 2 methyl group, then here aldehyde group is present like this. Okay. So this 2 methyl group shows a 39.7 strong signal because of 2 methyl group is equivalent, so they show the same signal here. Then because of nitrogen attachment, so here we can observe for this 154. How much? 154.1 singlet for this carbon. Okay. And because of nitrogen attachment, we can observe that strong signal here for the 131. So these two carbon 131.6 strong signal. Okay, because of these two carbons. So these two carbons show the same signal here. Also these two carbons equivalent by symmetry. So they also show the signal that is the 110.8 also doublet, that is a strong signal. And this carbon show the signal that is a singlet, but weak, that is the 124.9. 124.9, that is the singlet, that is a weak signal. Okay, and this because of carbon group, that is a 154. Sorry, 189.7, that is the doublet. Doublet indicates that carbonyl group is attached to protons. So this is also one of the important information. Doublet indicates that carbonyl group is attached to proton, means obviously aldehyde group is present in our possible structure. So in this way we can say that by considering all above data, that is the CMR data, we conclude that this is the possible structure for this CMR data. So in this way we can solve the problem based on CMR data. So in next lecture we will continue our discussion with same type of problem, that is the due to the structure from given CMR data.